The light comes when you're ready. What's coming, the bigger than anything we've done.
Welcome to today's deep dive. I mean, you already know data is running your enterprise,
Oh,
right?
absolutely. It's everywhere.
Yeah, and if you are navigating the modern business landscape, you're likely dealing with this constant, heavy pressure to optimize workflows. You've got to extract genuine enterprise-level value from these just massive streams of information your organization is generating every single day.
Right, and it never really stops.
Exactly. But today's mission, it's about moving past the limitations of, well, basic spreadsheet tabulations. We're unlocking the back-end architecture of Microsoft Power BI.
Which is a huge structural shift.
It really is. We are pulling our insights directly from a great source today, Microsoft Power BI for Dummies by Jack Hyman. We'll be looking specifically at how this platform takes chaotic, completely disjointed data sources and transforms them into highly structured visual intelligence.
Because that chaos is real.
Oh, definitely.
Yeah.
We want to equip you with the specific concepts and the actual mechanics driving this tool. So you can walk into your next strategy meeting sounding like the smartest person in the room with a clear understanding of the architecture that actually makes enterprise analytics possible.
And that transition, taking control of that architecture, it's critical for any organization today.
For sure.
Because the reality of the modern enterprise is that data collection is just ubiquitous. It is relentless. I mean, from the very moment you wake up in the morning to the time you finally go to sleep at night, some system out there is gathering data about you.
Yeah, your phone, your watch, everything.
Exactly. Even during sleep, background processes are generating records that correlate to some aspect of human behavior or business operation. But here is the catch. Raw data, simply sitting on a server somewhere, is functionally meaningless.
Right, it's just ones and zeros.
It really is. Without a sophisticated framework to translate those raw, isolated facts into actionable information, organizations are, well, they're essentially just hoarding noise.
Hoarding noise. I love that phrasing. And Jack Hyman actually points out something in the text that perfectly illustrates this exact shift in how we handle all that noise. He notes that less than a decade ago, the lowly spreadsheet was considered completely adequate.
Yeah, the gold standard, really.
Right. Adequate for collecting, measuring, and calculating complex data sets. But you fast forward to today, and the spreadsheet is widely considered a dinosaur in the context of enterprise analytics.
A total dinosaur.
In less than 10 years, it went from being cutting edge to completely prehistoric.
What's fascinating here is the underlying structural reason for that extinction event.
Right. Why did it die out?
It all comes down to the sheer volume and the velocity of modern data generation. Organizations are accumulating information at a speed that was just unimaginable a decade ago. They're generating these big data sets that frequently consist of millions upon millions of concurrent records.
Which a spreadsheet just can't handle.
Exactly. Simple tools built for basic tabulation, they simply buckle under that weight. A standard spreadsheet cannot evaluate multiple massive data sources simultaneously. It just can't do it.
It crashes. We've all been there.
Right. Nor can it reveal the hidden patterns and trends of human behavior when you're dealing with that kind of load. The architecture just isn't there to support it. You really need a dedicated approach that is built specifically for scale.
Okay, let's unpack this. Because handling that scale means dealing with the realities of how data is actually formatted before it ever even reaches an analytics platform. Right?
Oh, the messy data problem.
The headache of messy data. But Hyman outlines how Power BI specifically tackles the three primary data formats. First, you have structured data. This is the easiest to conceptualize.
It plays by the rules.
Exactly, it plays by the rules. It adheres to a predefined schema. We're talking about strict tabular formats with neat columns and rows. For instance, a U.S. zip code field that is restricted to only accepting numbers, or a strict binary Y for yes and N for no.
Right, and because that model is predefined, analytical tools can parse it effortlessly.
But the real challenge,
And where modern platforms really prove their worth.
yeah, is with unstructured data.
This is data that is completely ambiguous. There is absolutely no internal rhythm or reason to its formatting. We are looking at raw text documents, audio files, videos, photographs.
Stuff that doesn't fit in a box.
Exactly. The file itself might possess some rudimentary metadata attached to it, maybe a creation date or a file size, but the actual content inside remains unique. It defies neat categorization into a structured table.
It's notoriously difficult to parse automatically.
It is, yet it often contains the most incredibly rich, nuanced insights an organization can actually leverage.
Which naturally leads us to the third type, semi-structured data. This is kind of the middle ground. Hyman details how this format bypasses rigid relational tables, but avoids total chaos by utilizing tags and markers to establish hierarchies.
Right, it forces a level of organization.
Based on technical requirements, rather than a rigid table structure. You typically see this type of data living within NoSQL databases, where the flexibility allows developers to organize information logically without locking it into the strict constraints of a traditional SQL column and row setup.
Understanding those three formats is essential for you because the architecture of Power BI was specifically evolved to ingest and unify them all. And evolved is definitely the correct term here.
It didn't just appear overnight.
Not at all. The platform we use today is the result of a very specific phased development timeline that really mirrors the growing complexity of enterprise data needs. Hyman's source material notes that the roots of the platform go all the way back to 2010.
Wow, 2010.
Yeah, where it was originally conceived simply as a component of the SQL Server reporting team. It was just a back-end utility.
Here's where it gets really interesting, though. It didn't stay a back-end utility for long. By 2013, Microsoft integrated it into the Office 365 suite.
Right, as an advanced add-in.
Yeah, an advanced analytics add-in specifically for Excel. And the enterprise business community adopted it so rapidly that by 2015, Microsoft made the decision to strip it out of Excel entirely and launch it as its own entirely standalone product line.
A huge milestone.
And the final major evolutionary step mentioned in the text occurred in late 2019 when Power BI was merged into the broader Power Platform family. Now, it sits directly alongside related enterprise tools like Power Apps.
Which is used for custom mobile applications.
Right, and Power Automate, which handles workflow automation.
If we connect this to the bigger picture, that evolutionary timeline from a SQL backend tool to a standalone enterprise platform, it dictates exactly who this software is actually built for today.
Right, who's actually using it.
Because it has expanded far beyond the exclusive domain of IT professionals operating in some dark server room, the text outlines a wide spectrum of key roles that interact with the platform. On one end, you have business analysts.
The configuration gurus.
Exactly. These individuals often act as quasi-developers. They're the ones gathering requirements on the ground and configuring the platform to solve daily, field-level business problems.
Then you have the data professionals. Based on Hyman's breakdown, these are the heavy lifters of the ecosystem.
Oh, absolutely.
They are utilizing the platform to ingest those massive, voluminous amounts of data we discussed earlier. They build out the highly sophisticated back-end reports and establish the complex key performance indicators that the rest of the organization will eventually rely on. They are dealing with the actual data architecture.
And the third crucial demographic the book explicitly identifies is executives and managers. Now, their interaction with the platform is entirely different.
They aren't writing code.
No, they are generally not writing code or configuring back-end data streams. Instead, managers use the platform to understand the art of the possible.
The art of the possible. I like that.
They are looking at the overarching organizational goals and relying on the visual dashboards to make massive strategic decisions. They guide the analysts and the data professionals, basically defining what visual KPIs are necessary to steer the company.
And this directly impacts you, listening right now. Regardless of your technical background, whether you're the data professional writing the complex ingestion scripts, the analyst configuring the daily reports, or the executive asking your team for a high-level visual dashboard, the platform is designed with a specific entry point tailored exactly to your operational needs.
You don't have to be a back-end developer to extract value.
Exactly. You don't have to be a coder to get massive strategic value from this ecosystem. But to actually utilize it, we do need to look under the hood at the mechanics of the software itself, because Power BI isn't just one monolithic application.
No, it's a bundle of tools.
Right. It's effectively an analytics Swiss Army knife. The source reveals 5 different powers operating beneath the surface. So let's break down the workflow, starting with how data actually enters the system.
The extraction engine driving that initial ingestion is called Power Query. Its dedicated function is to connect to disparate data sources and just pull that data in.
From anywhere.
Anywhere. We are talking about extracting from standard CSV files, relational databases, cloud platforms like Azure, or even social media APIs like Facebook. But the underlying mechanic that makes Power Query function is a hidden functional formula language known simply as M.
Just the letter M.
Just M. This language handles the heavy lifting of transforming and organizing the raw, chaotic data into usable, structured tables before it ever reaches the modeling phase.
So once M has executed that extraction and the initial formatting, the workflow moves into the modeling phase with a tool called Power Pivot.
This is where the architecture really takes shape.
Yeah, Hyman explains that Power Pivot allows users to build out complex diagrams and star schemas. It defines the specific relationships between all those different tables you just extracted. Yeah. And crucially, Power Pivot abandons that M language entirely.
Right, a complete shift.
Instead, it utilizes a completely different formula language called DAX, which stands for Data Analysis Expression. DAX is the engine you use to create sophisticated mathematical calculations and multidimensional measures across your newly defined data model.
It allows for a level of analytical depth that standard spreadsheet formulas simply cannot execute. They can't even come close.
So M is for the pull, and DAX is for the math.
That's a great way to summarize it. And once the data is extracted via M and modeled via DAX, the platform shifts to the presentation layer. This is handled by the visual engines, Power View and Power Map.
The fun stuff.
Exactly. Power View is responsible for the interactive elements most users are familiar with, the standard charts, graphs, and interactive slicers that allow you to filter data on the fly.
But Power Map is wild.
It introduces a highly specialized spatial dimension. The source highlights that Power Map integrates directly with Microsoft Bing to map geospatial coordinates.
Which is incredible.
It really is. This integration allows users to generate complex 3D map renderings based on highly granular specific addresses or even massive global regions, adding an entirely new layer of geographical context to the data model.
The final power in the bundle, though, completely shifts the paradigm of how users interact with that data model. It's called Power Q&A, and it serves as the artificial intelligence engine built directly into the platform.
This is where it gets really futuristic.
Yeah, Hyman details how this tool bypasses the need for DAX or SQL entirely for the end user. You can simply type a plain English question right into the interface. A user could literally ask the system how many users purchased a specific item at a given store location on a Tuesday.
And it just knows.
The AI engine interprets that natural language query, scans the complex DAX data model you establish in Power Pivot, and automatically generates the answer as a visual output. It completely removes the technical barrier to querying massive datasets.
It fundamentally changes the accessibility of the data model. But to author these models and subsequently share those AI-driven insights, users have to navigate the dual environments of the platform. The source makes a strict distinction between the two.
Right. Desktop versus cloud?
Exactly. The first is Power BI Desktop. This is the localized, all-in-one authoring software that you install directly on your machine. It bundles Power Query, Power Pivot, and the visual engines into a single interface, and it is completely free to use.
But is isolated.
Yes, inherently isolated. If you intend to share your architecture or collaborate with colleagues, you are required to transition to Power BI Services, which is the cloud-based companion platform accessed via app.powerbi.com.
So what does this all mean when you actually make that transition to the cloud? Hyman issues a specific warning here regarding Microsoft's proprietary terminology. The text notes that Microsoft playfully refers to its specific vernacular as concepts.
You really have to learn their language.
You do. Navigating the cloud environment requires a firm grasp of these foundational concepts, starting with two major structural pillars: capacities and workspaces. If we look at capacities first, we are talking about the literal physical hardware resources required to process your analytics. We are dealing with the underlying server storage, the processor power, and the active memory.
And the platform divides these physical resources into two distinct tiers. The first is shared capacity. This is the default free tier, and the mechanics of it mean your analytical workloads are essentially bouncing off the pooled resources shared by other Microsoft users across the server.
Right, you're sharing the lane.
Exactly. It is functional for lightweight tasks, but it is inherently limited by that shared environment. The alternative is dedicated capacity. As the name implies, this tier means Microsoft has fully partitioned and committed specific servers and processing power exclusively to you and your organization.
But that's going to cost you.
Yes, because it guarantees high-level performance without shared bottlenecks. Dedicated capacity requires a premium enterprise subscription.
Okay, so once your underlying physical capacity is established, you need a structured environment to house the actual analytics projects. That introduces the concept of workspaces. These act as the primary containers for all your ongoing work.
Your datasets, reports, dashboards.
All of it. The default container provided to every user is called My Workspace, which serves as a private free area intended solely for personal consumption and testing. However, the moment a project requires team collaboration, where multiple analysts or data professionals need to edit, publish, or manage a report simultaneously, the standard My Workspace is insufficient.
You have to upgrade.
Right. Collaborative workspaces require users to upgrade their licensing to a pro or premium tier, which unlocks the administrative controls necessary for team-based authoring.
Moving from the containers themselves to the data living inside them requires an understanding of the back-end enterprise architecture. The text gets into some deep structural mechanics here, specifically distinguishing between data flows and data sets.
This part always trips people up.
It does. A data flow functions as the active process pipeline. It is a collection of tables utilized specifically for data transformation. A dataset, conversely, is a static asset. It is a specific, finalized subset of data that has been fully imported, modeled, and is now ready to be attached to a visual report.
And at the enterprise scale, handling millions of records, these datasets are frequently mapped to what Microsoft calls an Azure Data Lake.
The Azure Data Lake concept is a critical piece of the architecture. When an organization is dealing with the voluminous amounts of unstructured or semi-structured data we discussed earlier, standard databases just choke.
They can't handle the pipeline.
The Azure Data Lake takes on the incredibly heavy lifting of the operation. It is designed to process, clean, and store virtually bottomless oceans of data at incredibly high speeds. Because the data lake handles the raw processing power on the back end, Power BI is freed up to query those massive data sets almost instantaneously on the front end.
To ground that abstract architecture in a practical reality, the source provides a highly memorable operational scenario. Imagine you are working within the administration of a massive hospital system, and a critical emergency occurs.
A real all-hands-on-deck crisis scenario.
Exactly. The administration does not have the luxury of time to manually cross-reference filing cabinets or wait for a standard relational database to slowly compile a staff roster.
Every second counts.
Instead, utilizing a Power BI report that is directly mapped to an Azure Data Lake, the administration can instantly query tens of thousands of employee records. Within seconds, the system can filter those records and display exactly which essential personnel live within a 5-mile radius of the facility, enabling the administration to mobilize a targeted response team immediately.
That hospital scenario perfectly illustrates the transition from raw data to actionable intelligence. The report takes a complex, multi-layered data set spanning millions of potential rows and translates it into an immediate visual output.
A map, a chart, whatever they need.
Whether that is a geospatial rendering powered by Bing, a trendline chart, or a donut chart displaying departmental availability, it essentially turns administrative panic into a highly structured, actionable strategy. But Hyman also highlights a critical security mechanic regarding how users interact with a report during a scenario exactly like that one.
Right, because you don't want someone accidentally deleting data during an emergency.
Exactly. The interaction is heavily governed by user permissions to protect the integrity of the data. The vast majority of users responding to the crisis will experience the report exclusively in Reading View. This is a strict, read-only interface. It allows users to view the data, utilize the slicers to filter information, and make decisions based on the visual output, but it physically prevents any accidental or malicious changes to the underlying data model during a chaotic event.
And the alternative to that?
The alternative is Editing View. This interface is restricted entirely to the authors of the report and requires specific administrative member or contributor rights. The Editing View unlocks the back-end mechanics, allowing authorized personnel to modify the visual layout, adjust the DAX formulas, or alter the data flows in real time.
It really is the phenomenal structural overview of the platform. We started by looking at the severe limitations of single, isolated spreadsheets, struggling to process high-volume data without crashing. And through Jack Hyman's text, we have unpacked the architecture of a dynamic, cloud-based ecosystem.
A complete paradigm shift.
You now understand the workflow pipeline, where vast streams of unstructured big data are extracted using Power Query in their M language, mathematically modeled using DAX within Power Pivot, and seamlessly queried using plain language AI via Power Q&A.
The tools are all there.
The next time you are tasked with optimizing an enterprise workflow or trying to make sense of disparate NoSQL data lakes, you possess the specific structural concepts necessary to transform that raw data into a compelling, interactive visual narrative.
And this raises an important question, something for you to consider as we conclude our analysis of the source material. We discussed the natural language capabilities of the Power Q&A AI engine, its ability to instantly interpret our everyday speech and query millions of rows of data on demand.
Just by typing a question.
Right. But if the artificial intelligence driving these platforms is already that sophisticated, how far are we from a structural shift where the analytic system no longer waits for our specific prompts? We may be rapidly approaching a future where the data architecture proactively analyzes the enterprise and asks us the critical business questions we haven't even thought to ask yet.
Wow. An analytics platform that anticipates the strategic needs of the enterprise before the executives even realize there is a blind spot.
Wow.
That is a profound structural shift to consider. Thank you for joining us on this deep dive into enterprise data analytics. Keep exploring the architecture of your workflows, keep analyzing your systems, and above all, keep questioning the data around you. See you next time.
This is Cortex Lab. I'm Ishanka. We break down complex ideas, AI, resilience, future tech, so you can level up. Join the journey, rewire your thinking.